So we are moving to the second example, still under sums and products of the roots of the quadratic equation. But for this case, we are going to form an equation. Example 3. The roots of the equation, 2x squared minus 5x minus 4 equals 0 are alpha and beta. Find the equation whose roots are part A, alpha squared, comma, beta squared. Part B, alpha plus 1, comma, beta plus 1. Part C, alpha squared beta, comma, alpha beta squared. Solution. So this question is somehow different from what we have been doing, but we have not changed anything there. For this case, we are saying find the equation. The other side we are finding the values. One, find the equation whose the new roots have been given to you. So the same story, if they say the roots of the equation this and this are alpha and beta, still we are using alpha and beta as the roots of that equation. The first step is first get the sum and the products of that equation which is being given to you. We are having the roots, the equation is 2x squared minus 5x minus 4 equals 0. So the first step is divide it out by 2 to have remain with a coefficient of 1 on the side of x squared. So we are going to divide by 2, divide by 2, divide by 2, divide by 2. So we are remaining with x squared minus 5 out of 2x minus 2 equals 0. So can we get what we call sum of roots? We get sum of roots, which we are calling alpha plus beta. The sum of roots, when it is negative, it will automatically become a positive. The sum of roots, which we are calling alpha plus beta, equals 5 out of 2. We also look at the product of roots, which we are calling alpha beta, is automatically equal to negative 2. Then from there, we are going to start with part A. Part A is talking about the new roots now. We have got alpha squared and beta squared. Now, when you have got the new roots, I expect you also to first get the sum of the new roots. So we are going to get sum of new roots. We're going to first have sum of new roots. Sum of new roots, it means we are adding those roots which are given to you and which are new to us, which are going to be alpha squared plus beta squared. So the sum of new roots is alpha squared plus beta squared. Now, this one is an identity which we know, which I have already derived, and we can easily substitute in them. So this one becomes alpha plus beta, the whole of it squared, minus 2 alpha beta. Do we know alpha plus beta? Alpha plus beta is already 5 out of 2. So we substitute it, we say 5 out of 2, the whole of it squared, minus 2 into, what is alpha beta? Is negative 2. So what are we getting? This is 25 out of 4 plus a 4 out of 1. We are free to find the LCM. So our LCM equals 4. 4 divided by 4, we are getting 1. 1 times 25, you come out with 25 plus 4 divided by 1, 4. 4 times 4, it is 16. So when we try to add on it, it will become, when you try to add this and this, we are going to come out with 41. So it will be 41 out of 4. This is the sum of new roots, a sum of new roots. So we also get the product of the new roots. So can we also look at the product of new roots? Product of new roots. The product of new roots, remember our new roots are alpha squared and beta squared. So we are now multiplying the two. Sum of new roots is going to be alpha squared times beta squared, which becomes alpha beta, the whole of it squared. Do we know alpha beta? Alpha beta, we have tried to pull out the square because it's common everywhere. So what is alpha beta? Alpha beta is already -2. So it becomes -2, the whole of it squared, which becomes 4. So our equation which they want us to get is given in terms of x squared minus sum of roots. Sum of roots, so we are talking about those new roots, plus the product equals 0. That's the question which we're going to be using. Even we used it yesterday when we are finding how we are forming roots of the quadratic, where we are forming equations. So what we're going to do, we substitute this is x squared minus, do we know the sum of roots? Sum of roots is already 41 out of 4x, plus the product is already 4 equals 0. So automatically when we reach there, what is the LCM? The LCM is 4. You can multiply by 4 throughout. This one becomes what? Comes 4x squared minus 41x plus 16 equals 0. You have already finished forming an equation whose new roots are being given to you. That's how we handle such kind of the numbers. So we are going now to move to part B on how we can form an equation when we're given those roots. So that's how we do it. They are enjoyable the moment you practice them perfect, and the more you practice, the more you become perfect. But if you don't practice, you will not even get it. The little even which you have will just evaporate from there. So my humble appeal and request is always and always practice these numbers so that at the end you can achieve the best. So we are going to part B. The new roots are alpha plus 1, comma, beta plus 1. We also need to get some of these new roots. And get some of new roots. Some of new roots. Some of new roots. It means we are going to add those roots which we have, which is already alpha plus 1, alpha plus 1, again plus beta plus 1, which becomes alpha plus beta, then plus 2. Do we know alpha plus beta? Alpha plus beta is already 5 out of 2. So we shall say 5 out of 2 plus 2. Can get the LCM. So the LCM is 2. 2 divided by 2, you get a 1 times 5. That's already 5. Then plus 2 divided by 1, you are getting a 2 times that, 4. Then 5 plus 4, automatically it becomes a 9 out of 2. 9 out of 2. Then we also get the product of new roots. Product of new roots. Product of new roots is a matter of multiplying the two new roots which are there, which is alpha plus 1, again into beta plus 1. So this one becomes alpha, can use layman's, alpha into beta plus 1, then plus 1 into beta plus 1. So we are free to open alpha times beta. You are getting alpha beta plus alpha, then plus beta, then plus 1. But we have already got alpha plus beta. What is alpha plus beta? Is already 5 out of 2, and alpha beta is already -2. So go ahead and substitute. This is -2 plus 5 out of 2, then plus 1. -2 plus 1, you are getting -1 plus 5 out of 2. Then you are free to find the LCM. So when you find the LCM, you are automatically going to come out with 3 out of 2. Then from there, we are going to apply our formula, which is x squared minus sum of roots, that is x, plus the product equals 0. So we substitute in, this is x squared minus, do we know sum of roots? Our sum of the new roots is already 9 out of 2. We say 9 out of 2, x, then plus 3 out of 2 equals 0. So look at the nature of our denominator. The denominator is carrying a 2. So multiply this out by 2. What are we going to come out with? This is 2x squared minus 9x plus 3 equals 0. This is the required equation which they wanted you to come out with. So that's how we handle a number related to that nature. What is important for you is first get the sum of the roots which have been given to you. After getting them, go ahead and get the product. After there, go to the new roots. Also get for them the sums and also get the products of those new roots which are within you there. Then from there we can move to part C. Part C. We need to go to part C. We form that equation which is moving to on part C. So our part C is having what we are calling alpha squared beta as the new roots, alpha squared beta, comma, alpha beta squared. So the same story, get the sum of the new roots. So can we get sum of new roots? Sum of new roots are going to be, you add the 2. What is it? It's going to be alpha squared beta plus alpha beta squared. What is common here? What is common is alpha beta into alpha plus beta. So do we know alpha beta? Alpha beta is already negative 2 into 5 out of 2, which is already negative 5. We also come to the product of the new roots. So go ahead and look at the product of new roots. So the product of new roots is all about multiplying these two roots which have been given to you, which will be alpha squared beta times alpha beta squared. This one becomes what? We move on. When we multiply alpha squared times alpha, we are getting alpha cubed, then beta cubed, which becomes alpha beta, the whole of it cubed. Do we know our alpha beta? Our alpha beta is automatically negative 2. So we are getting negative 2 cubed, which is negative 8. Then from there, we are going to apply in. It's going to be x squared minus sum of roots x plus product equals 0. So we get x squared minus, do we know the sum? The sum is already negative 5. So we shall have it there, negative 5x plus the product which is negative 8 equals 0. Then we are free to rearrange it very well. A negative and a negative, we are getting x squared plus 5x then minus 8 equals 0. That's the way how we normally handle such a kind of equations which are related to that one. So whenever you find this number like that, automatically think of one thing. Am I having my products? Am I having my sums? Or both for the roots which have been given to you and for the new roots which are being given to you. Then get used with the identities. When you are not used with the identities, automatically you will not get the fruitful results. So I request you practice more open up on our backhouse 1, then you will get all those questions, then you'll be free to calculate all of them without any interference with that. So we are going to go to another example. That is example 3. Example 4, not example 3. Example 4 goes, the roots of the equation 2x squared plus 3x minus 2 equals 0 are alpha and beta. Find an equation whose roots are part A 1 over alpha, 1 over beta, part B alpha squared plus 1, beta squared plus 1, part C alpha minus 1, beta minus 1. Solution. So what we're going to do is that, as the question is being stated, that the roots of the equation 2x squared plus 3x minus 2